Hi everyone, this video is for section 7.3, double angle identities. In this particular problem, we're going to solve for this equation cosine of 6x minus the cosine of 3x is equal to 0. We do have a restriction here, and we do want to be careful when we read it. So our restriction, we want to find all answers. In other words, we want to find all the possible answers for the variable x that will fall in that range from 0 to 2 pi, where 2 pi is not included, hence the reason for the parenthesis next to it. So to begin, I'm going to rewrite this problem so I can kind of clearly indicate that I can use a double angle identity. So I'm going to rewrite 6x as 2 times 3x. So hopefully everyone agrees with me that I can decompose it in that way so that they match up. So I'm going to move this over and get rid of that straight green line. And I'm going to write in what I remember about double angles. So I remember that if I have a cosine of 2 times alpha, where alpha is my angle, I can have it equate to one of three things. It could be the cosine squared of alpha minus the sine squared of alpha, being careful to not accidentally mix this up with your Pythagorean identity, where remember that it's a plus sign in between those two. It could also be equal to 1 minus 2 times the sine squared of alpha, or it could be 2 times the cosine squared of alpha minus 1. Ideally, when we're solving problems like these, we would like to try to keep the trig functions just to 1. I don't really want to ever have to mix in sines and cosines together. So that being said, I'm going to scratch off the first two options. Also, what I want to note here is that my 2 theta is going to mirror my 2 times 3x. So, or sorry, not my theta, my alpha in this case is going to be equal to 3x. So I'm going to go ahead and rewrite this. So this is going to become 2 times the cosine squared of 3x minus 1, and then minus that cosine of 3x. 3x is equal to 0. So I'm going to do just a little bit of rearranging. So I'm going to use my additive commutative property, or my commutative property for addition, I should say it that way. So I'm going to rearrange this so that everything is in descending order according to the degree attached to the cosine. And what I'm going to do from here is I'm going to use my u substitution. So I'm back to what I had been doing in section 7.1. I noticed that I can rewrite this so that it could look like a quadratic, and now I'm going to use some u substitution to basically clean it up. So this is going to give me 2 times u squared minus u minus 1 is equal to 0. So from here, what we can go ahead and do is we can go ahead and factor this down. So this is going to give me 2u plus 1 times the quantity of u minus 1 is equal to 0. Feel free to pause the video and double check my work if you're not sure or if you want to catch up. So from here, we can use our zero product property. So if we know that these two quantities multiply together to equal 0, we can say, well then 2u plus 1 is equal to 0, or u minus 1 is equal to 0. So we can go ahead and isolate u now. So we'll subtract 1 from both sides, and we'll get 2u is equal to negative 1, and then divide both sides by a 2. And we reveal that u is equal to negative 1/2, or if we take it out of its substitution, we know that the cosine of 3x is equal to negative 1/2. Similarly, if we add 1 to both sides on our second equation here, we get u is equal to 1, or in other words, the cosine of 3x is equal to 1. So I'm going to scoot that up. And here we can use our unit circle here to help us out because we actually have some nice common angle measures here. We're also going to want to employ our cosine inverse or our arc cosine here. And that is going to reveal the following to us. We're going to know that 3x could be equal to 2 pi thirds, which is going to be in our second quadrant, which is where one of our groups of cosine values are going to be equal to a negative number. We'll also get 3x is equal to 4 pi thirds. And also, if we come over here, we'll note that 3x, in this case, if we take the arc cosine of 1, we'll get 0. Now, recall that you could go ahead and argue, well, what about 2 pi? But remember, we have a range restriction that goes from 0 to 2 pi, where 2 pi is not included. Okay, so here's the extra kicker. We want to find all x values that are going to fall between this range that I have here. So in order to do that, and again, this might seem newer, what I'm going to go ahead and do is I'm going to add 2 pi to 2 pi thirds, 4 pi thirds, and 0. And I'm going to do it for at least 3 times, and you'll kind of see why. So if I add 2 pi to 2 pi thirds, I'm going to get 8 pi thirds. If I add another 2 pi to that, that's going to give me 14 pi thirds. And if I add another 2 pi to that, that's going to give me 20 pi thirds. Similarly, if we do that here, this will give me 10 pi thirds, 16 pi thirds if I add another one, and then if I add another 2 pi, that's 22 pi thirds. And then lastly, we would have 2 pi here, 4 pi here, and 6 pi here if I kept adding 2 pi to everything. So again, you might be kind of going, we've never done that before, this is new. But it's really just a situation that's never come up for us. So what I want to note here is I wanted to kind of lay out a bunch of options for myself before I solved for x. And here is why. When I multiply each of these by 1/3, in other words, to get rid of that 3, and I'm going to do that again for all of my cases. So bear with me, and you're just going to hear some tapping and probably the sound of my voice because I never know when to be quiet. We're going to see the following happening. Okay, so here are our solutions. I'm going to note these down in a dark blue. So we'll get 2 pi ninths, 8 pi ninths, 14 pi ninths, 20 pi ninths, 0, 2 pi thirds, 4 pi thirds, 6 pi thirds, 4 pi ninths, 10 pi ninths, 16 pi ninths, 22 pi ninths. Okay, so right now I have all of these solutions. Oops, I made an error over there. Sorry, everyone. Let's go ahead and clean that up. That should be a third down there. I don't know why I put a 6. I guess I got carried away. We want to go ahead and make sure that all of these numbers are actually going to fall in this range that I have boxed here. So I intentionally overshot to make sure that I did get all the solutions. So 2 pi ninths falls in there, 8 pi ninths falls in there, 14 pi ninths falls in there, but 2 pi ninths doesn't. It actually goes beyond our 2 pi, or if you wanted to do the decimal approximation of 6.28. If 2 pi ninths, if 20 pi ninths doesn't fit in there, neither would 22 pi ninths. But these all will. You can double check using your calculator if you want. 0, 2 pi thirds, 4 pi thirds, they all fit, but 6 pi thirds just misses the cut, because if we simplify that down, it does become a 2 pi. But remember, the 2 pi has a parenthesis next to it, so we can't include it in our solutions. So actually, in this particular problem, we have 9 whole different answers. I hope this explanation was helpful. If you do have any other questions, please let me know.